Now let's define a logarithmic function and a hyperbolic function. Now, basically a logarithmic function is another way of writing down an exponential function, right? So if you have this function here, x is equal to a to the power y, right? Where y is the input and x is the output in this particular case, but the definition says that y is the output. So how will you write down this y as the output, right? How will you write down y as the dependent variable here? So you need to think of some way, and that way is through a logarithmic function. So you can write down x is equal to a to the power y like this, where the exponent becomes the dependent variable, and that will be equal to the log with the base a, which is the constant here, into log with the base a of the independent function, which is x, right? So just another way of writing down x is equal to a to the power y is equal to the logarithm with base a of x. And you don't need to worry about what this basically is, because you have this particular function in your calculators. So you can just simply calculate this, right? Now, a must be greater than 0 and a must not be equal to 1. Those are the only two conditions here, right? So if they are, then, well, tough luck, honestly, because if a is equal to 0, in that case, you'll just get 0 on this side, because 0 to the power anything is just 0. So both sides will become 0. And when a is equal to 1, again, that's just 1 to the power of something, and again, that just becomes 1. 1 to the power of a million is equal to 1, right? So fulfill these two conditions, and that is what you call a logarithmic function of x. If a is equal to 10, then we have a log with the base 10, and that can be written down as just log of x. Instead of writing down log with the base 10 of x, write down log x. That's the same thing. You have this in your calculator as well. It is known as the common logarithm of x. Now there's another one. If a is equal to e is a certain value. I don't really remember what the value is in digits, but it's a value, and you have this in your calculator as well. So when a is equal to e, you can get log with the base e of x, and that is the natural logarithm of x. And you can write down, instead of writing down log with the base e of x, just write down ln x, ln being the natural logarithm. Now, hyperbolic functions. I won't really go into too much detail here, but sine hyperbolic of x. What is the sine hyperbolic of x function? That's basically e to the power x minus e to the power negative x over 2. That's just what it is, honestly. It's just something you'll have to memorize, or it'll be given to you, but you just have to remember. This is known as the hyperbolic sine function. Its domain and range are the set of all real numbers, right? So this is the beauty of this particular function, is that the domain and range are a set of all real numbers. Now you have cos hyperbolic of x. The only difference between sine hyperbolic of x and cos hyperbolic of x is this sign between the two exponential functions, right? So in the sine hyperbolic of x, you get a negative sign, and in the cos hyperbolic of x, you get a positive sign. This is called the hyperbolic cosine function, and its domain is the set of all real numbers, but the range is a bit different. So basically, the y value ranges from 1 till infinity. So basically, y is greater than or equal to 1. That's the range, okay? And the remaining 4 hyperbolic functions are defined in terms of hyperbolic sine and this hyperbolic cosine function. So basically, for example, tan hyperbolic of x is basically just equal to sine hyperbolic of x over cosine hyperbolic of x, just like you had it in the trigonometric functions, right? And here's what it is. Once you simplify it down, you get this. And again, cotangent hyperbolic of x is just the reciprocal of tan hyperbolic of x. So you just flip down, take the reciprocal, right? So you have this, and then you have secant hyperbolic of x, which is just the reciprocal of the cosine hyperbolic of x. And then you get this. And cosecant hyperbolic of x is just the reciprocal of sine hyperbolic of x, and you get this. Simple, really. You can see that the hyperbolic functions have the same properties that resemble to those of the trigonometric functions. I think we've established that fairly well over here, right?